Hi guys, today we are going to do a pedigree example, and so I thought I'd model one for you. This is all about superheroes, so each get your own unique example to work with your team. So what we're going to do is read this, write down some important information, and then refer back as needed. So please follow along. Jacob and Jennifer both come from families with long histories of having the superpowers of duplication and animation. Duplication, Jacob's power, allows him to make physical copies of himself. Animation, Jennifer's power, allows her to bring inanimate objects to life. Geneticists studying superheroes have learned that these powers follow an inheritance pattern of autosomal recessive, with animation being recessive to duplication, which is the dominant form of this trait. So let's write down what we know so far. We've got Jacob and Jennifer. Jacob's superpower is duplication, and Jennifer's is animation. Doesn't hurt to write this down so you don't forget. Now this is an autosomal trait, which means it's like a regular chromosome. It's not a sex-linked trait. So let's start our key. So we know duplication is dominant to animation. So we use a capital letter D to represent the dominant allele. Animation is recessive. Let's go back. Jacob and Jennifer are hoping their first child will be able to duplicate like his or her father. So they have come to you as their genetic counselor with their family history in hand to try and get some answers. On your pedigree, the people whose symbols are completely shaded will express the recessive phenotype, animation, and those who are unshaded will express the dominant phenotype, duplication. Individuals with half-shaded symbols are carriers for the recessive trait. For individuals with unknown superpowers, draw the appropriate symbol based on their sex and draw a question mark inside their symbol. Include all this information in your family key or legend. Okay, so let's finish our key. Okay, so you could be a carrier of animation. You could be unknown. Okay, and our genotypes would be, if you express duplication, you're homozygous dominant. If you have animation, you're homozygous recessive. If you're a carrier of animation, it's the same as saying heterozygous. And unknown, we just leave the genotype blank. So we also need some symbols for male and female. So male, female, male, female, male, female, male, female. For duplication, we do not shade it in. For animation, the recessive trait, we completely shade it in. If you're a carrier of animation, we half shade it in. And if you're unknown, we'll just do question marks. Okay, so there's our key. Okay. Next up is to do the pedigree. So let's look back. So in this chart here is where you're going to find the family history. So Jacob's family, siblings, he has a sister that expresses duplication. His parents, his dad expresses duplication. His mom expresses duplication, but she's a carrier for animation. In Jennifer's family history, she has one brother that expresses duplication, a carrier for animation. Parents, her dad expresses duplication, carrier for animation, and mom expresses duplication and a carrier for animation. Okay, so I don't expect you to memorize that, but you can refer back to your worksheet as needed for that information. So let's start with Jacob's family. And we're going to write out the first generation, his dad and his mom. His dad expresses duplication. His mom is a carrier for duplication. Okay, so Jacob has one sister who is homozygous dominant for expressing duplication. And here's Jacob. And we know that Jacob expresses duplication, but we do not know his genotype because it wasn't included in the family history. So here's his wife, Jennifer. Okay, we know that she has the power of animation. So that must mean that she is homozygous recessive, so we're going to shade her in. So we do know her genotype here. Jen has a brother. He is a carrier for animation. And Jen's parents, her dad and mom, they are both carriers of animation. Okay, so they are hoping to have a super baby. Some kind of super symbol. Okay, and we want to label the generations 1, 2, and our potential 3rd generation. So we know everybody's genotype except for Jacob. So what do? Well, we do a Punnett square, and you learned this skill a while ago. So we know that he expresses duplication, but we don't know if he is homozygous dominant for duplication or if he's heterozygous for duplication, because he could be either, and Jennifer can only be one or the other. So Jen, let's draw a window here. Okay, or if Jacob is heterozygous, so I'm going to bring him down and bring him over, make a match. They have to stay in their columns and rows. Do both of them while we're here. Okay, so if Jacob is homozygous dominant for duplication, then the chances that he's going to have a child that duplicates is 100%. Okay, if Jacob is heterozygous, he has a 50-50 chance of duplication or animation. Okay, so that's pretty much it for this example. However, some of you are going to have some scenarios that are X-linked or sex-linked traits. So just if this was a sex-linked trait and not just autosomal, let's write that out. So remember, males are XY, right? And if a male is going to have the trait of duplication and it's X-linked, meaning it's on his X chromosome, he would have to have a dominant allele to have duplication. Okay, if a male had a recessive trait, it would be animation. Okay, females are XX. So a female can have duplication by having 2 dominant alleles, homozygous. Now remember, each X has to have the allele for this trait if it is X-linked, because women have 2 X's, so she would be able to duplicate. If she was X dominant allele for duplication and recessive allele for animation, she would still show the power of duplication because the dominant masks the recessive. The only way that we can get a female that shows animation is if she has 2 X's that are homozygous recessive. Okay, so I hope this helps, and please do your very best work.